All right, everyone. Welcome back. So this video is kind of a continuation of the last video where I introduced those three laws of exponents that we talked about. And in this video, what we're going to do is kind of practice those skills, right? We're going to practice 5 problems using just the concepts from that video, right? So without further ado, let's get into it, right? So I've written problem 1 here already. And so the goal with all these problems is just to simplify them, right? That's what the goal of really exponential problems is at least in part, is to kind of get practice with simplifying these expressions, right? So yeah, let's take a look at this problem, right? So what it says is, number 1, it says, so basically what we're doing is we're simplifying 36xy, and that whole thing is being squared, right? Times x to the negative 1, right? Divided by a to the x times a to the y minus 1. And so, okay, so right off the bat, the first thing I'm going to do is I'm going to kind of highlight the parts where a law is going to come into place, right? So I'll just use the red color here. So right off the bat, we can see here that, okay, this 36xy being squared, well, clearly we're using law 2, right? Because we have something in parentheses, right, being raised to an exponential power, right? We're not combining two things with the same basis, right? So that's the first indicator here that we're supposed to be using law 2, right? So law 2 is going to be used to clean up this first part, right? And so to the right of that, right, we have an x to the negative first power, right? So based on that, we discussed how to deal with negative exponents to the first degree, right? So we'll be using that property to deal with x to the negative 1, at least initially, right? And on the bottom here, we just have kind of basically exactly what law 1 is. We have a to the x times a to the y, right? So we're going to be using law 1 to kind of consolidate those exponential powers there, right? So I'll underline that. Okay. So let's take a crack at this, right? Let's start solving it. Okay, so the first thing I'm going to do is I'm going to simplify this 36xy squared, right? So essentially all we need to do is, because we're just squaring the whole of 36xy, it's really less of a reliance on those exponential laws and more just knowing how to square a term, right? So we can rewrite the 36xy as 36xy times 36xy, because we're just squaring it, right? And when we simplify this, right, we can multiply it out, right? So what we can end up doing is we can multiply the 36 by the 36, right? Just by properties of multiplication. So we'll get 36 squared times x squared times y squared, right? That's perfectly fine. But what I'm going to do in this example, right, is we can just directly apply law 2, right? We can take this square and we can multiply every single part of the term by but we can square every single part of the term, right? And so we can rewrite this as 36 squared times x squared y squared, right? Great. So that's the first part of this top that's being consolidated, right? And the second thing we're going to do is simplify this x to the negative 1, right? So the first thing we need to do with this is, okay, recognize that x to the negative 1, right, is the same thing as 1 over x, right? So we can just rewrite this based on that property as 1 over x. So this whole thing's being multiplied by 1 over x. Great. Okay. So that's the top. We can simplify this a little bit further. And let's do that now. Why not do that now, right? So we can apply our third law here, right? We have an x squared here, we have an x squared here. So essentially what we're doing is we have x squared over x times 36 squared times y squared, right? And so we can apply that third law. We have x to the 2 minus 1, right? This becomes x to the 2 minus 1. And so this is just x times 36 squared times y squared, right? That's our top being simplified. Okay, so I'm going to erase this. I'm going to write the whole simplified thing back in the original place, okay? Great. So this, as we just showed, simplifies the 36 squared. I'm just going to leave it as 36 squared because I don't feel the need to expand the whole number out. It's perfectly fine. We know what it is, right? Times x times y squared. 36 squared xy squared, right? Great. And that's being divided by this part. Let's simplify that over here. Minus 1, right? That's just a 1. Okay, so based on our knowledge of the first law, right, we can These have the same base, right? So all we need to do here is we need to add the powers together, right? Put a plus sign there. And so we can rewrite this as a to the x plus y, right? The whole power of x plus y. And then we're just subtracting a 1, right? And we don't need to do anything with the 1 because it doesn't have the same base as the a. There's nothing we can really do to simplify that, right? It's perfectly fine to have a 1 there. Okay, so then we can take that over here and just write this as a to the x plus y minus 1, right? We've consolidated everything. We've removed all the extra parentheses, all the extra terms, right? Great. And so with that being done, right, we can consider this expression fully simplified, right? And so our final answer would be this. 36 squared times xy squared, right? Divided by the whole thing, a to the x plus y minus 1, right? And that would be our solution for problem 1 in the review problem set, right? Great, so let's try another problem here. And this one's going to kind of introduce us to some new topics, right? The problem here we're going to try to address, let me just make that line a bit clearer, is we're going to have some different expressions going on here. But in the end, what we're going to end up doing is we're going to have this problem beginning with, we're going to have x to the negative 1, right? And we're squaring that. Then we're multiplying it by z cubed, right? And then we're dividing by 2 zy to the negative first power, right? And so this one it definitely looks a bit more intimidating at first because we have some different stuff going on with, our negative powers. And, we're going to have to do some different types of simplification to fully simplify this expression. But overall, we can address it with those same laws, right? So in the first part here, we have x to the negative 1, right? Which we know how to simplify. That's just 1 over x, right? And we're squaring this, right? Okay. Well, we can actually apply our second law here, right? Because we have an a here and a b here. They're both numbers, so our second law is perfectly applicable. Assuming this was an a and b, right? We could rewrite this as x to the power of negative 1 times 2, right? Just by that second law here. We're not violating anything by doing that, right? And so that's one way we can simplify this originally, right? Great. So I'm going to call this simplified, right? Even though we don't have a fractional form for this, I'm going to call this simplified. I'm going to call it x to the negative 2 power, right? That's the simplified version of this, right? And then we're multiplying it by z cubed, but right now we can't do anything with that, so I'm going to leave it as is, right? Great, so the second part of this expression we have to deal with, I'll ignore the 2 for now because it's just a constant, right? It's not going to impact any of these variables we're dealing with, right? Is this zy to the negative 1, right? And so again, we can apply that second law, right? These are both to the first power, and so we can split them up and we can multiply each one by negative 1 to simplify this expression to give us z to the negative 1 times y to the negative 1, right? Okay, so now we've gotten somewhere. We've removed all those extra parentheses and we're ready to start kind of applying the laws to actually get some consolidation happening here, because now we have a z isolated out of the parentheses. We have a z on the top, right? The y may not change, but that's okay, right? Okay, that's perfectly fine. We're ready to begin, right? So we can rewrite this whole thing. This is equal to, put the z out here, z cubed times x to the negative 2. That's being divided by z to the negative 1, y to the negative 1. Great. So right off the bat here, these are two separate expressions. We can put them in parentheses like this. The first one we're going to deal with here in our consolidation process is this z to the negative first power, right? Which we can just apply our third law. It's still, we can our division of same bases, right? And we can use subtraction, right, to consolidate this part. So we have, by applying the law, we're taking negative 1 away from 3. So it's z to the 3 minus negative 1, right? Is our full simplification there by law 3. And one key thing to notice here is that, well, okay, it's a negative minus a negative, which means that, which is very cool, is that this is actually going to give us a whole positive power. And this makes sense logically, right? Because z to the negative first is just 1 over z. And if we take, as an example, if we take z cubed times 1 over z to the negative 1 over z, right? We know that in fractions, we flip this and we can multiply, right? We can multiply both sides by z, right? The top and bottom by z over z. Oh, that's not the right way to do it. But when we're multiplying by 1 over z, right? Which means we're actually, these cancel and we're multiplying by z, right? Oh, it's not on screen. But at the end of the day, it gives us the same answer. It gives us z to the fourth because we're multiplying by the reciprocal of a fraction, right? Perfectly fine, perfectly legal multiplication operations when dealing with exponential expressions like this. So that's done. So we can start writing our final answer, which will contain z to the fourth, as we just showed. Okay, so z to the fourth. And then the next thing we have to address is this part, right? And we can't do anything with these expressions right now. And the reason for that is because, well, we can't do anything with them, regarding each other, right? But one thing that, a lot of teachers ask for, and it usually looks nicer, is to actually bring all those negative exponents to the top if possible, or to remove all the negative exponents from the problem entirely if possible. And there's a way we can do that, right? So, recall that, well, y to the negative 1, right? I'm going to erase the z to the fourth here. It's just 1 over y, right? So we have, if we just consider this part for now, which is fine because we just consolidated the z to the fourth, we have x to the negative 2, right, times 1 over y, right? Right, and since we have 1 times 1 over y, all we're considering is the reciprocal of 1 over y, since we're taking the reciprocal of 1 over y right here by dividing by 1, which is just y, which means this is just x to the negative 2 times y on the top, right? And so since this y doesn't have a negative exponent anymore, we can actually just bring the y right over here to our final answer, right? It's just nicer not to have negative exponents because if you have all positive ones, the final answer just looks a little nicer. It's really a preference thing, but a lot of people, again, do ask for it. And that's the reason I'm doing it in this example. I mean, I do consider it fully simplified in a way. Okay. The next thing we have to do is deal with this x to the negative 2, right? And so the way we deal with this is we ask the question to ourselves, okay, how can we consolidate x to the negative 2 using what we've learned in the last video? Okay. Well, x to the negative 2, right, this is a bit of a leap here. It's really just the same thing as x to the 0 over x squared, right? That's reasonable, right, since x to the 0 is just 1. And when we subtract this, we get x to the 0 minus 2, which is the same thing as the above expression, right? So this is legitimate. So we can write this x to the negative 2 as 1 over x squared, right? And that's the same thing, right, as multiplying this expression times 1 over x squared. Instead of times x to the negative 2 on top, it's times 1 over x squared on the bottom, right? Great. So now we've gotten rid of all the negative exponents, and we're ready to write our final answer. Okay. I'm just going to rewrite this as z to the fourth y over x squared. So that's our final answer. And it's quite nice how this problem cleans up. It's just, a couple exponential manipulations using the laws here. Great. Okay, that's problem 2. Now we just have 3 more left to go, and then we're done. Okay. So the third problem here is going to be a bit of an interesting one, but all we're going to have is kind of a test of, an understanding of, how these operations might affect exponents, right? So I'm going to write here, we'll have 2, right, to the negative 1 power, right, to the negative 1 power to the third power times 2 cubed, right? So here's a nice problem where it looks a little crazy first because we have these double parentheses, but really we're dealing with numbers in this case, so our answer doesn't have any variables in it, right? We can have an answer, since we're dealing with the same bases here, in terms of the base of 2, right? Because we can consolidate this answer at the end, right? So the first thing we have to deal with in this question is, okay, how do I even approach this double parenthesis thing that's going on here, right? Well, I can tell you this is really a continuous or a double application of law 2, right? The law that deals with exponents being multiplied by an exponent at the top of a parenthetical expression like this, like 2 times n to the m, right? In a case like that, where we multiply the 2 exponentials, right? That's all we're doing here. So we have 2 to the negative 1, right? And then the first thing we do is we multiply these two, right? We apply the law the first time, right? We're applying it outward, right? That's how we're going to consolidate them. Great. And you could do it any way you wanted. That's just the way I'm going to approach this problem. You could consolidate them however you'd like, right? This is just we're just applying that second law here to help us with this problem, right? So we get 2 to the negative 1 times 1. And then we can simplify that now, okay? Negative 1 times negative 1, sorry, which is just 2, right? Okay, so then we just have 2, and then we have to deal with this last one here. So now we just have 2 to the third power, right? Which is just 2 to the third power, right? And so then the next step is we just take this 2 to the third power and we multiply it by the other 2 to the third power, right? And then we can just apply that first law, right? And we just add the powers. We get 2 to the 3 plus 3, which gives us a final answer. I'm write it up here of 2 to the 6th, which is 64. But I don't really think that's as important as understanding how to perform the manipulations here, right? The key in this problem is understanding how to apply that you can apply the law of things like this, right? This is like a to the m times k, right? So based on that, and then we're raising that whole thing to the third power. So we can address the first part in the side in the center first, and then we can raise it to the third power, right? We could also do it this way, just to kind of avoid some confusion with these, because you can do it multiple ways, right? We could also approach it this way. We could say, okay, our our inside expression 2 to the negative 1, right, is being raised to this power, is being raised to the power, or 2 to the negative this thing, right, is all being raised to the third power. And then we could say, okay, this is our inside expression, right? And so then we just multiply this by this, right? As a first step, we would get 2 to the negative 1 to the negative third power, because we're treating this whole thing as our a, and this as our inside thing as our n or our m, right? And this is as our k. So we're gonna begin by consolidating these two outside expressions, right? And then the next step would be applying the law again in the reverse way, and then you would get 2 to the third that way. But either way you decide to apply law 2, it's still going to give you the same answer. That's all I wanted to stress. Great. So now we only have 2 more problems left, which is great. Moving along here. Okay. Problem 4. What if we had something? How would we simplify a problem that's like we had the square root of x squared, right? Something like that, times x cubed times x to the 4th divided by x to the 16th. And then the whole thing is being squared. So it's the first time we've seen something like this, right? How do we deal with this, right? And so everything in here is being multiplied, right? So we can apply law 2 to the whole expression, and we can apply law 1 inside the expression, right? So let's begin by doing that. You could do it in any order, by the way. Okay, so the first thing to notice, the square root of x squared. What is the square root of x squared? Well, if I have x squared, right? Okay, any x squared, right? That's just x times x, right? If I take the square root of x squared, right? I'm essentially undoing the square, right? I'm taking the square, I'm getting back to x, right? Because x and x multiplied by itself twice will give me x squared, right? So essentially, because it's being multiplied by itself twice, it's giving me x squared, right? And so if I take the square root, I just get back to x, right? That's the first thing to notice. So we can actually erase this and we can rewrite it fairly simply as x, right? Perfect. So it's just x times x cubed times x to the 4th divided by x to the 16th. Okay, so let's consolidate this, right? That's just going to give us x to the 1 plus 3 plus 4 by law 1 divided by x to the 16, right? So we're going to get a negative exponent in this operation. That's fine, right? So let's say what is this? This is 4. This is 8. This is x to the 8th, right? Divided by x to the 16th, right? Perfect. Now let's use that third law again. X to the 8 minus 16. So that's giving us x to the negative 8, right? Perfect. And now I'm going to erase this and we're going to rewrite the whole thing, right? Since the inside is x to the negative 8, right? We're just taking x to the negative 8 and we're squaring it, right? Perfect. That's all we're doing here, which gives us an answer of x to the 16th, negative 16th rather. Okay, how can we rewrite this nicely? Well, I'm gonna use a different approach to get to an answer with no negative exponents. But one way to think about it is that, right, n, where n is any number or expression, to the negative 1 is 1 over n, right? So I can rewrite this x to the 16th, right? Just want to make sure everyone can see that, right? I can rewrite the x to the negative 16th, right, as x to the 16th to the negative first power. That's perfectly legal, right? Because when we use law 2, we're going to get back to x to the negative 16th. And if we assume our x to the negative 16th is n, right, then n to the negative first power is 1 over n. So using that relationship, we can deduce that x to the negative 16th is 1 over x to the 16th, right? Perfect. So that's how we're going to write our final answer. There's no negative exponents in there. It's a perfectly clean answer. It's correct. And that kind of reasoning with using that laws is one of the best ways to approach these problems if you're unsure. Great. Only one more problem left. So this last problem is going to be kind of a more challenging one, since we've done a lot of all the problems we've done so far have just used law 3 in pretty straightforward ways. The next problem is going to bring us into the next video that I'm going to make, which is going to be on roots of numbers, which is like exponents that aren't necessarily whole numbers, right? How do we deal with those? So the last question I'm going to pose is, okay, and I'll explain this. It's going to be a segue into the next video. But the question is, what is the square root of x in terms of an exponential power? So x to some n, right, equals the square root of x. So what might that n be, right? So this is how we're going to start. Well, we know what a square root is, right? A square root is two numbers that multiply together to give us x, right? So we have x is equal to the square root of x times the square root of x. These are those two numbers that multiply together to give us x. They're square roots, right? Just like 64 equals 8 times 8. The square root of 64 equals 8. Perfect. That's most people know that it's when you have a perfect square number, two numbers multiplied together, two of the same numbers multiplied together gives you that number, right? Okay, so suppose we just had x, right? We are essentially asking the question, okay, let's rewrite these square root of x's as x to the u, right? We're going to assume they can be expressed as some power, right? We can say, okay, can we rewrite square root of x as x to some power, right? Using the laws of exponents. Is that possible? Is there an equivalent way to write it? Just like how negative exponents are related to fractions, in the end of negative 1 is 1 over n. Is there a way to bring square roots into that same world, right? Can we use, for example, fractional exponents to represent square roots? And the answer to that question is yes. And it's because of the definition of the square root, right? So we can say, okay, this is x to some u times x to the same u, right? Because these are the same things, so they're going to be the same with the same u, equals x. And this is x to the first, right? Okay, so we can use our first law here, right? So we can use our first law. We have u plus u. So we know x to the u plus u is equal to x to the first, right? Okay, and so now, right, we'd have to make these powers the same. So essentially what the same question is saying is, okay, when is u plus u equal to 1, right? In order for these to truly represent the square root of x, they have to be the same thing, and u plus u has to equal 1, right? Okay, so that's just an equation. Okay, so that means that 2u, right, because we can just consolidate the u's, equals 1, and u is equal to 1/2. It's kind of an amazing fact, right? So I'm going to erase this, and let's see if it's true. So based on that, our guess and basically a true statement is that the square root of x is equal to x to the 1/2, right? And the reason is they both satisfy the same property. They're the same number. And x to the 1/2 times x to the 1/2 equals x. These are both the same number in both cases, and they both multiply by one another to get x. And so based on this, we can say that our conclusion is that the square root of x is equal to x to the 1/2, right? And that's where I'll leave this video off. I guess the question I would leave you guys with is, what other fractional exponents can we find? Like, what is x to the 1/3? What is x to the 1/4? Just take some guesses at it. Maybe that's what I'm going to talk about in the next video. I'm also going to do a recap of the square roots, right? All right, great. So with that said, I'll write out the next topic here. So next topic, it's roots and fractional exponents. This is going to continue with the laws of exponents, but it's going to go deeper and it's going to allow us to solve more types of problems. Great. So I'll see you guys then.